Welcome to the module on well stimulation. Today we will learn about perforation, definition and purpose, acidization and its types, acid additives, factors affecting acid reaction rate, potential formation damage, acidizing candidates and selection, hydraulic fracturing and equipment, operation stages, fluid properties, frac job package setup, multi-stage fracturing and horizontal completions, fracture orientation, and acidizing versus fracking. Well stimulation is a well intervention operation performed in oil and gas well to enhance its productivity by improving the hydrocarbons flow from drainage area into the wellbore throughout cleaning the formation, removal of formation damage, extending the perforation tunnels, fractures, and wormholes. Fracturing treatments are performed above the fracture pressure of the reservoir formation and create a highly conductive flow path between the reservoir and the wellbore. Matrix treatments are performed below the reservoir fracture pressure and generally are designed to restore the natural permeability of the reservoir following damage to the near wellbore area. Perforation, definition and purpose. Perforation is punching holes in the casing or liner of a well to connect it to the reservoir. Perforation guns are run on E-line as it uses electrical signals from surface to fire the guns. In more highly deviated wells, coiled tubing may be used. Purposes of perforation are creating a channel between the pay zone and the wellbore, allow oil and gas to flow to the wellbore easily, and future formation stimulation, for example, hydraulic fracturing, perforating guns, casing gun. It create holes in a casing string. Casing guns are typically 3 to 5 in diameter and carry up to 4 perforating charges per foot. Allow perforation through production casing using larger diameter gun assembly. Expendable gun. A perforating gun assembly which disintegrates upon firing, creating finer debris. It is used where wellbore restrictions allow only limited access, as in through tubing applications. Retrievable gun. It is retrievable from the wellbore after firing. It generates minimal debris and minimum distortion of the gun body to help ensure easy retrieval. High shot density gun. A perforating gun have more than 4 shots per foot. It improves the facing, or distribution of perforations, around the wellbore and enables improved distribution of the perforations around the circumference of the casing or liner. Acidization. Acidization is the matrix treatment which is accomplished by injecting chemicals into the formation to dissolve and or disperse materials nearby the wellbore, which impair the well production to create new, unimpaired flow channels, or wormholes, between the wellbore and formation. Types of acidization. Carbonate acidizing. Carbonate formations generally have a low permeability and highly fissured. HCl is used as basic rock dissolution agent. Wormholes form in the process of dissolution of the rock. Other additives are used as per the compatibility with rock minerals. Sandstone acidizing. Mud acid, HCl plus HF, is used as basic rock dissolution agent for acidization of sandstone reservoir. A pre-flush of HCl of organic acid is normally used prior to injection of mud acid. Additives are selected based on the rock mineralogy and reservoir fluid properties. An overflush is injected to push all the mud acid to formation. Acid additives in general. Corrosion inhibitor, surfactant, non-emulsifier, anti-sludge agent, iron controller, mutual solvent, friction reducer, clay stabilizer, and diverting agent. Factors affecting acid reaction rate. Pressure, temperature, flow rate, acid concentration, area is to volume ratio, formation composition, and secondary reactions. Potential formation damage from acidizing. Loss of near wellbore compressive strength due to excessive HS dosage either in volume or concentration. Formation of emulsion or asphaltic sludge due to incompatibility between the acid and production fluids. Water blocking and wettability alteration damage. Fine migration after acidizing. And for sandstone acid stimulation, the resulting permeability improvement peaks at certain acid volume and then drops as the volume increases in oil wells. Acidizing candidates. Wells may perform poorly or less than expected due to 3 factors: improper mechanical system selection, wrong tubing sizing in a flowing well or artificial lift equipment for gas lift wells, low reservoir permeability, and wellbore restriction due to formation damage and complete perforating. If the problem is formation damage, then matrix treatment may be an appropriate treatment to restore production. Acidizing candidate selection. A good matrix acidizing candidate is any well producing from formation with permeability greater than 10 meters d. Permeability near wellbore or perforations region has been reduced by solid plugging, drilling fluid/long-term production. This plugging can be due to either introduction of suspended solids in a completion, workover fluid, or dispersion of in situ fines by incompatible fluids and high velocities. Chemical plugging caused by mixing incompatible fluids which precipitates solids, hydraulic fracturing. Hydraulic fracturing is a well stimulation technique in which rock is fractured by a hydraulically pressured liquid. A high-pressure fluid, usually chemicals and sand suspended in water, is injected into a wellbore to create cracks in the deep rock formations through which natural gas, petroleum and brine will flow more freely. Objectives of hydraulic fracturing: bypass nearby wellbore damage, increase well production by changing flow regime from radial to linear, reduce sand production, increase access to the reservoir from the wellbore. Hydraulic fracturing equipment: slurry blender, one or more high-pressure, high-volume fracturing pumps, monitoring unit, fracturing tanks, one or more units for storage and handling of proppant, high-pressure treating iron, chemical additive unit, low-pressure flexible hoses, many calibrated pressure gauges, calibrated flowmeters, and fluid density meter. Frac operation stages: 1. Acid stage, spearhead, water mixed with diluted acid such as HCl to clear cement debris in the wellbore and provide open conduit for other frac fluids by dissolving carbonate minerals and open fractures near the wellbore. 2. Pad stage, approximately 100,000 gallons of slick water without proppant material. The slick water solution, pad, opens the formation and helps to facilitate the flow and placement of proppant material. 3. Prop sequence stage, consists of several substages of water combined with proppant material, fine mesh sand or ceramic material, intended to keep open or prop the fractures created and or enhanced during the fracturing operation after the pressure is reduced. 4. Flushing stage, consists of volume of fresh water sufficient to flush the excess proppant from the wellbore. Frac fluid properties: compatible with the reservoir, low leak-off rate, ability to carry the propping agent, low friction loss, easy removal from the formation, stability at reservoir condition, availability, and safety cost economics. Let us see a visual illustration of frac job package setup. Multi-stage fracturing in horizontal completions. Purpose: fracture acidizing, matrix acidizing, and formation damage removal. Applications: open hole horizontal and vertical wells, sandstone, carbonate and naturally fractured formations, and critical sour and HPHD environments. Advantages: customized simulation of the entire wellbore in a single, continuous operation, isolate individual stimulation stages, distribute acid evenly across stimulation intervals using jet nozzles, achieve jetting action on formation through jet nozzles, isolate water, shale, or other undesirable sections of the wellbore, determine production from selected intervals, and re-stimulate desired intervals. Fracture orientation: hydraulic fractures are formed in the direction perpendicular to the least stress. Horizontal fractures occur at depth less than approximately 6,000 feet because the Earth's overburden at these depths provides the least principal stress. If pressure is applied to the center of a formation under these relatively shallow conditions, the fracture is most likely to occur in the horizontal plane, because it will be easier to part the rock in this direction than in any other. As the depth increases beyond approximately 6,000 feet, overburden stress increases by approximately 1 pound per square inch per foot, making the overburden stress the dominant stress. Since hydraulically induced fractures are formed in direction perpendicular to the least stress, the resulting fractures at depths greater than approximately 6,000 feet will be oriented in the vertical direction. Acidizing versus fracking. Let us see a brief comparison. Thank you for learning with us.